You are welcome to Hajjady math class. In this video, we will be treating modular arithmetic. In our previous videos, we've been able to look at number-based system, the conversion from base 2 to base 10, from base 10 to other bases as well. So the same knowledge of the number-based system will be adopted in modular arithmetic. In number-based system, we are more concerned about the remainder. If a number is given to you in base 5, all the digits involved should not be up to the 5, neither should it be greater than the 5. So the same thing is applicable if you are given a number in base 5, you have digits from 0, 1, 2, 3, 4. So the same rule will be applicable to modular arithmetic, whereby we are more concerned about the remainder. So even in modular arithmetic, if a number is given to you, let's say you have number in mode 3, all the digits involved should not be up to 3. You can have 0, 1, and 2. That's all. Should not be up to the 3. You have number given to you in mode 5, all the digits involved should be 0, 1, 2, 3, and 4. This is more or less like the remainder whenever any of these mode values is being divided. So, looking at the word given to us here, we have that the example. Sorry, please, I need to clean this for us to have a proper channel to work. Okay. Now, looking at this, express the following numbers in mode 3. The first question, you are expressing 25 in mode 3. This is very simple to do. We have 25. We want to express it in mode 3. There are two ways of doing this. The first one might look a little bit tedious, but let's go with that. 25 in mode 3. Let's look for the multiples of 3. That will be very close to 25, and the multiples of 3 that is close to 25 is 3 times 8. 3 times 8 gives what? 24. So what are we going to add to our 25? We have plus 1. This 1 is our remainder. Is our what? Our remainder. So you can express 25 as 1 mod 3. Alternatively, you have 25. You want to express this in mod 3, you can say divided by 3. This gives what? How many 3 can we see in 25? We have 8, remainder 1. So that shows that this is equivalent to 1 mod 3. I hope you understand the first example. Thank you. So the same step will be adopted to the second example. In solving the second example, I would like you to pause the video for some minutes and try the second example using any of the methods adopted in the first example. Now looking at the second video, we have 19. You want to express 19 in mode 3. You can have 19, the first method, equals, what is the multiple of 3 that is close to 25? 3 times 6 gives what? 18. Plus what? 1. It can be 1, 0, or 2. So that means you have it also in 1 mod 3. Or you say 19 divided by 3, you have what? 6, remainder 1. So this is equivalent to what? 1 mod 3. But in a situation whereby you have, maybe you have the third example as maybe 15 in mode 3, this can be 15 over 3, which is what? 5 remainder 0. This shows that you have what? 0 mode 3. So this is how to express numbers in a particular mode. Let's see more examples using another mode. For solving this second example, we would like to express the following numbers in mode 7. The same method will be applied. We have 23. We are expected to express this in mode 7. Now, in expressing this in mode 7, we have multiples of 7 closer to 23 is what? 3 times 7. This gives what? 21 plus 2. That means we have this in form of 2 mode 7. Or alternatively, you have it to be 23 over 7 gives what? 3 remainder 2. And this is equivalent to what? 2 mode 7. 2 mode what? 7. So this solves the first example. I will leave the second example as an assignment, and I would like you to put this in your what? In this comment section of our channel. So let's move to another aspect of it. Now we are moving to the basic operation of modular arithmetic, and when we talk about the basic operation, we have the addition, the subtraction, the multiplication, and in this section we are looking at the addition table for mode 3 and also for mode 5. For you to do this, I told you expressing numbers in mode 3, you have values from 0, 1, and 2. If it is in mode 5, you have 0, 1, 2, 3, and 4. So in this case, we are using from 0 to 0 to 2 rather. So we have the addition sign, we have 0, we have 1, and we have 2. So we have this, and in this case, we have the same thing, 0, 1, and 2. Don't forget, the maximum digit you can have is 2. Now let's add this. We are adding this plus this using this sign, 0 plus 0. Then you move to 0 plus 1. And lastly, 0 plus 2. The same thing will be used. So here we have 0 plus 0 is what? 0. Also we have 0 plus 1. We know that is what? 1. And lastly we have 0 plus 2, and that is 2. We move to the next line, which is 1. 1 plus 0, 1 plus 1, 1 plus 2. So let's move to 1 plus 0. This gives us 1. Also, 1 plus 1. This gives us what? 2. And lastly, we have 1 plus 2. Naturally, this will give you what? 3. But don't forget, we are working in mode 3. And for you to do this, that means you divide this by the mode, which is 3. And here we have what? 1 remainder 0. Like I told you, we are more interested in the remainder. So here you have what? 0. You come back to 0. 1, 2, 0, 1, 2, 0, like that. And in the next one, we have 2 plus 0. We are still within the limit of 0, 1, 2. So you write 2. Here we have 2 plus 1. We have 3 also. Using the same method here, 3 over 3, which is 1 remainder 0. Here we have 0. And lastly, we have 2 plus 2, which is going to give us what? 4. And you divide 4 by the mode, which is mode 3. We have this. 4 over 3 is 1 remainder what? 1. Like I told you, we are writing this remainder. So we write what? 1. So looking at this, this is addition table for modulus 3. Modulus what? 3. So this is the addition table. So next we look at mode 5. So for modulus 5, the same thing will be done. We have 0, 1, 2, 3, 4. Addition, we have 0, 1, 2, 3, 4. So in doing this, we have 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3, 0 plus 4. So in this case, we have 0 plus 1 to be 0, 0 plus 1, 1, 0 plus 2, 2, 0 plus 3, 3, 0 plus 4, 4. Please don't forget that the highest digit we can have is 4. That is the maximum. So moving to the next line, we have 1 plus 0, 1 plus 1, 1 plus 2, 1 plus 3, and 1 plus 4. So in doing this, 1 plus 0 you have 1, 1 plus 1 you have 2, 1 plus 2 you have 3, 1 plus 3 you have 4, and 1 plus 4 you have 5. Don't forget we are working with mode 5, so you have 1 plus 4, which is 5. You divide by the mode, which is 5. You have what? 1 remainder 0. So you get to here 0 here. Now next line, which is 2 plus 0, 2 plus 1, 2 plus 2. So in this case, 2 plus 0 we have 2, 2 plus 1 you have 3, 2 plus 2 you have 4, 2 plus 3 you have 5, that will be 0. 2 plus 4 you have 6. So you have 6 over 5. It gives 1 remainder 1. I told you we are interested in the remainder. Now we are moving straight to 3. 3 plus 0 you have 3. 3 plus 1 we have 4. 3 plus 2 we have 5. And like the one we did here, 5 gives remainder of 0, while 6 gives remainder of 1. So you have 0, 3 plus 3, which is 6, gives remainder of 1. 3 plus 4 will give remainder of what? 2, because 7 over 5 is 1 remainder 2. The last one, which is the 4. 4 plus 0, you have 4, plus 1, 0, 1, 2, 3. Got this something funny here. Let's look at it row and diagonally. We have 1, 1 here, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4, 0, 0, 0, 1, 1, 2, 2. So that's one funny thing about it, in such a way that you can easily fill in the rest yourself. So in our next video, we move to multiplication table involving modular arithmetic. Thank you very much, and please Don't forget to subscribe to our YouTube channel. Have a wonderful day. Thank you.